I wanted to spend a little bit of time walking through how I got my Three.js website or landing page for my personal site up and running, and talk a little bit about some conceptual things, some minute, fine-tuned technical things that helped this site get up and running. Hopefully this can help someone. There's a few questions I had that I couldn't find really good answers to on Stack Exchange or the Three.js forum, so I really had to do my best to figure stuff out, and I tried a bunch of stuff. To get into it, this is using FBO particles as a system to simulate a brain. I wanted to get the sense of neurons firing in the brain, and I'm looking here because I'm basically looking at my monitor right now. What's cool, what I think is cool at least about this landing page is it's really simple, really clean. The black and white looks good. Also, it's not super resource intensive, so this can run even on a phone. I tried it. Also, you can orbit the camera and zoom in and out, like no problem. You can pan, you can do whatever you want. However angle you want to look at the brain, you can totally do that. I think it looks pretty clean. My About Me page is similar, where instead of a brain, there's a torus on the right side that uses the same particle system. I have some text about myself on the right side as well. I tried to make it look just elegant and clean. The reason I chose the brain is because it's my favorite internal organ system in the body, and I think it's so ultra complex and we don't understand a lot about it. I'm also very interested in the philosophy of mind, which is different from neuroscience, but they come together in really interesting ways. And this brain model, I guess that's a helpful thing to start with. I didn't sculpt this myself. I got it online. I think it was Sketchfab. I downloaded the blend file and then exported it to GLB. Three.js, in my understanding, works best with GLB files or GLTF. We'll see that in the code here. Let me go ahead and open up the code for this. So if I scroll up, this stuff at the beginning is pretty simple, just straightforward stuff to get situated with the HTML file. We have CSS. One thing I should mention offhand too is I didn't make separate files for style CSS sheets and then the JavaScript files. That's best practice. I just wanted to get it up and running, and I found that it was easier for me to get everything in one HTML page so I could see how things are flowing and connecting. If I was trying to do really super clean work, I would have separated them. It's better, I think, and best practice. But my thought was, hey, I just want it to work first. And this does work, fortunately. That's why everything's on one page. Okay, moving past the CSS. This body stuff, this is just the curtain. So this black curtain up here is covering the top part, and it's inverting the colors from the brain. So that's why the top is white, or rather the top portion of the brain is white, bottom portion is black. Okay, getting to one of the first interesting things for Three.js. Let's say you're working with different shaders, like fragment shaders and vertex shaders. I could not figure out how to use the GLSL files and integrate them well to be able to publish online. It just was being weird for me. Fortunately, I was able to find a post, I think on Stack Exchange, that talked about how to set these up. So you essentially want to put them into a script file, and the script ID for a fragment shader should be fragment shader, and then the type, you can put X shader, X fragment. Why on earth is that? The type is basically syntax. I think you could really put anything like Jim Bob or potato and it would still work. But as long as it's not a type, in my understanding, that's already pre-specified by some other popular type, I think that should work. The ID is helpful for us as we can reference it and be like, oh, this is the fragment shader script. And here's our actual code for that. Vertex shader, similar. This code is a lot longer, but this allows the particle system to work the way it does. I won't explain this right now. This is more conceptual. I also have a fragment simulation. These all work together to be able to create this effect. One challenge of this effect is essentially we don't want the particles to start in one position and then move out and then never come back. Getting the particles to look cool so that they go out but then end up returning to their original position or somewhere close to it is mathematically kind of difficult, but it can work. So this is how you do it. For context, I wish I had the ingenuity to come up with this all myself. I watched a really good tutorial for getting the FBO particle system working. I can link to that below. However, publishing it was a different matter that I had to figure out on my own. So this is hopefully going to help someone at least a little bit. Okay, getting down to some other stuff. We have the import map for Three.js. I found that this worked best for me, where I referenced the CDN website for Three.js, and that was able to integrate well. I will say that for orbit controls and GLTF loader, I did the same thing, where I found where they were on the CDN website repository, and that worked well. However, when it came to the GPU computation renderer, which is another thing I need to get this effect working, that was not working for the CDN import map for me personally. So what I did is I manually found every line of code I needed for that GPU computation renderer, and I just put it right into this module script. This is one of those things where there's way better ways to do it. This is not a clean way, but it works. And for me, I just wanted it to work. So we're importing all this stuff. I want to explain all this. Basically, a bunch of these lines of codes, I think it's like 200 lines, are just for the GPU computation renderer. So we can go down here. This is still computation renderer. Cool. Oh, that's a lot more than 200. Okay, but now we're getting into something I wanted to explain a little bit. So these commented out lines are all examples of code. Can I zoom in? Yeah, okay, let me do that. These commented out lines right here, 886 to 896. These are all different. Oh, wow. I don't know why it's going from. Oh, I can't count. Okay. Anyways, these are all the GLSL files that I had originally. I'll mention too, for context, my first attempt trying to publish this site was using Node, npm, npx byte, and publishing it by doing npm run deploy to GitHub. There's a method to do it that way, and it just was not working for me. That's why I went this route. But theoretically, when you do it that way, npm run deploy, that should be able to integrate all your files like this, where you have a shader folder with your different GLSL files. And theoretically, that should work. It was not working for me. I tried to debug it. I ended up just going this route. Also, the brain file, the GLB file, it's called brain4. And let me see. I'm pretty sure I have a line. So, yeah, okay, cool. So instead of importing the brain from the file directly, what I did was in the loader, the line to load the GLTF, I essentially, yeah, that's fine. I essentially included a link to where I decided to upload the file on GitHub. All that to say, if you want to upload a GLB file and integrate it to a Three.js website, one way to do it, there's multiple ways, is to do what I did. Put the GLB file on a GitHub repo, a public GitHub repo, and then just include the link to the actual file. And that will work. So that worked for me. All this stuff is setting up the Three.js sketch to be able to display the shape, so the brain shape with the shaders, with the math, etc., etc. Setting up the camera as well. One thing I'll mention here, there's a ton right here of gltf.scene.children, index 0.children, index 0. This took me a second to figure out too, because if you're uploading a custom GLB file from Blender, let's say, you need to figure out where in the hierarchy your actual mesh is. Because for me, the mesh was very deep in the hierarchy. It was not the first child, or let alone the first index of the first child. It was way down. Like, it was literally the first index, or I guess the 0th index of the 6th child, or the 6th set of children. Sometimes it'll just be weird like that. I don't know. But that ended up working. All right, let's keep going down. That's just more cool math. Okay, yeah. What's nice too is once you get to a point where you've modeled or rather you've set up all your files correctly, you've set up the math, the shaders correctly, it's actually a very simple change to make it so that you can use other stuff. So I can't edit this right now, but if I was in VS Code and I wanted to change this, it's a really simple change to be able to switch between models if you want to try out different stuff. So these two lines are saying, hey, use the brain model I've set up in this GLTF loader right here. But if you want to quickly try out other models, you can set them up similarly, like this, and then you can call them and be like, hey, instead of using the model geometry for the brain, why don't I use a sphere or an icosahedron or something different? And that becomes really easy to be able to switch up. Like I said, if you upload different GLB files, you can switch between them pretty easily. That's totally cool. All right, the rest of this is just rendering out, ending the script, and then that's it for that one. So just to recap, why did I want to make this video? I wanted to talk about some of the things that were cool about and challenging about making this landing page. I wanted to mention the GLSL files and uploading the GLB files and making them actually work for Three.js. I've mentioned there's better, cleaner ways to set up your Three.js files and set them up to be able to publish online. That said, this works, and I'm glad it works. If you have constructive feedback, let me know. I'm totally happy to improve in terms of the landing page and the structure of the files, for sure. Hope that was helpful to someone.